Hello, quick introduction to the video. My name is Cameron. I'm a graduate apprentice software engineer currently studying at Glasgow University, and I'm using this video as a way to sort of rubber ducky debug a LeetCode problem. Just attempt to solve it, talk through my thought process, and hopefully it's useful to someone watching this. So, the problem I'm going to be attempting today is problem number 155, min stack. So we're just going to read out the spec here. We have to design a stack that supports a push, pop, top, and retrieving the minimum element all in constant time. So we have to implement the class which has minStack, which is just like the constructor method that initializes the stack object. Void push int val, so pushes an element val into the stack. A pop, which will remove the element from the stack, from the top of the stack. Top, which will get the top element, and min, which will retrieve the minimum element in the stack. And we have to implement a solution that will give O of one time complexity for each function. So, just going to go over to notes here. And I'm going to copy over everything we need. So, ideas. We need to initialize a stack object, which is going to have a list in it, right? So we need a list to hold elements, right? We also, I think we should also have a variable just to hold the minimum element. So int variable holds min element. Okay, push int val is just gonna append, right? So append val to the list. Pop is just gonna remove item at index -1, right? So it's gonna go get the last item that was added. Top is just gonna return item at index -1, and get min is going to return the int, or it's going to return min element. So so when we push an item on to the list, we should check if val is greater than min element, or if it's less min element. If it is, set val to min element. But then when you remove element from the top of the stack, you then have no way to get the minimum element. So we need some way to track the min element. Also, when you're adding, you can just check if whatever you're adding is smaller than whatever's in that min element value. But if you're removing items, there's no way to actually tell. That would be an O of n if you had to go through and check again. Let's have a look in the spec here, because I saw there's some hints. Hints, we got one hint. Consider each node in the... Oh, that's interesting. Consider each node in the stack having a minimum value. Okay. Um, I don't even think we need to have a node. We just have to have a history, right? We can just do... We can have a history, so we have a list to hold elements, we have an int to hold the min element, but we also have a list. No, we don't have a min int, we have a list to hold history of min elements. So we append val to the list. We check if val is less than the min element. If it is, or if we set not min element, we check if val is less than history list at index -1. If it is, we append val to history index or history list. Yep. And then we remove index item at index -1 on elements list, or in elements list, and in history list as well. Cool. So let's take this and we'll try and turn it into reality down here. So we need a list called elements, and then we need a history. We need a push, so we're going to do append. Well, let's just take this up here. So we want to do self, or can we just do elements? Elements dot append val history dot append, or we're going to say if val is less than history index -1, then we're going to do history dot append val. Cool. And then for pop, we're just going to do elements dot pop, or elements dot pop. And then we can do history dot pop. And then we're going to return for top, we're going to do return elements dot, no, elements at index -1. And then for get min, we're just going to return whatever's in history at index -1. Cool. Let's run this. There's probably a lot of syntax errors because I've not really done class-based stuff in Python a whole lot. Self dot, maybe? Self dot. Let's hit run. Min stack has no attributes elements. Let's look it up. Init class Python. We do self dot up here as well. Cool. Let's hit run. I need to add this down here as well. Hmm. Index out of range? Oh, first of all, we need to check if the history is empty. So if self.history is if the length of the history is not equal to 0, then we're going to check if the last element is, or we're going to check if the element that we're adding is less than whatever is the last item to be added to the history. Otherwise, if it's empty, we're just gonna do the same thing, just append it. So appended to history. Colon expected. Here we go. I have been running too much code. Come on. Type of bill has no len. Ah, okay. Brackets in the wrong place. Okay. Hmm. So we try and push -2. So we do self.elements.append val. So we append -2. We append 0. We append -3. So what is this last element here? This -2. Hmm. Um. Let's check that like the. In fact, let's just. We're gonna just print element self, because I'm not gonna try and just instead of doing like tracing through this, I'm just gonna see what happens. So -2 is minimum. No, no, oh right, because this is self.elements. Yep, so they are getting appended correctly. -2, then 0, then -3. Yeah, that's right. Okay. So self.elements, we're going to do self.history. So we should see -2, -2, -3. -2, -2. Hmm. Hmm. So each time we're going through this, it should be still appending. These should be equal lengths. So if the history is not empty, then we're going to check if it's we should have an else in here. So we're just going to repeat whatever was in there before. -2, -2, -3, yeah. Okay, so we got instantiating the mini stack the min stack, and then we push -2, and at that point -2 is the minimum. We push 2 is 0, -2 is still the minimum. Then we push -3, at that point -3 is now the minimum. We get min, -3 is the minimum, correct. We pop, which is, so we pop -3 from the stack, from here, and from here. Oh, I didn't put brackets here, that's probably why. Accepted. Okay, let's submit and hope for the best. Output limit exceeded. What does that mean? Oh, okay. Silly me. I kept in the print statements. So just gonna submit this now. And there we go, accepted. So thank you very much for watching the video. Hope it was useful to you in some way, shape or form. If it was, please leave a comment, or if you had some other solution that was a bit more simple or a bit more efficient or just, you know, different, please leave a comment down below. Love discussing these problems and their solutions. So, yep, thank you once again for watching the video, and I hope you have a great day.